in this session continue on a bit with more definitions in the context of strings. That will be just one square, and then we're done for strings. And then we head on to a new topic called Boolean logic, which is absolutely fundamental to computer science. So if you've done any computer science at all, you'll know how important Boolean variables are. What else on this board? So the next 4 sessions. So so 1/2, 2. So 4 squares, 2 sessions equivalent on Boolean logic. And for the last session, pretty much on like a new section 3 in chapter 0, so 0.3, that will be on the concepts of definitions and theorems and proofs. So we're starting to talk about the nature of proof and techniques for proof, because a lot of this course is mathematical, pure math, in the context of computing. So like theory of computation. You know, what is it to compute? What can be computed? What cannot be computed? And thinking about efficiency of computation. Why are some problems so difficult to compute, to solve, and why are others much easier, and various categories of difficulty and so on. So I've talked a bit about that before. Alright, so just finish off a few definitions in the context of strings. The word concatenation, that's the noun. The verb is to concatenate. Caten, I don't know, it's Latin or Greek, something to do with chain or links. So to concatenate, the verb, in the context of strings, is basically it's just to join, like connect. For example, say I have one string here, I call it X. That's on your, as you said, your left-hand side. And on your right-hand side, I have another string, different string, and I'll call that Y. Okay, so X and Y. Now, if I concatenate them, I just join them. So, so I get one longer string, right? Those two, X and Y, are now concatenated. Okay, they've been joined. And what that means is that the first symbol of Y, you know, this one where my thumb is, follows immediately after the last symbol of X, which is here. Right? So, and you can write that concatenated string as XY. Right? So, and what length will that new string have? That concatenated string? Well, if your first string X, say it has length M, and remember the length of the string. What does that mean? It's just the number of symbols used in the sequence. So say you have M of them for string X, then you have a second string Y, and let's say its length is N, so M, N, okay? And you concatenate the two of them, so you'll get a string XY. That's how you write it, a concatenated string. And if you look at it in terms of its individual symbols in the string X and Y, you'll have x1, x2, xm, right, because it's length m, and followed immediately by y1, y2, yn. So the total length of the string, common sense, is just m plus n. Okay. Okay, so that's concatenation, and you're doing that a lot in computer science. So it's a very useful term. You'll use that a lot in coming lectures. Now you can concatenate a string with itself, so instead of x and y you can just do x with X. Right? So you just get a repeat of the string, and you could do that. You could do that k times. Right? So X like k times, and you can rewrite that. 3 bars by definition. You can rewrite that as just like X to the k. Right? K is a positive integer, natural number, telling you how many times you have, well, how many X's you have in your concatenated string, right? So X to the K. Here's another term. In the context of ordering, you're placing in order. Lexicographic. Where does that come from? Something to do with a dictionary? Letters? I'm not sure. Anyway, the technical meaning is you say you have a whole bunch of strings, set of strings, let's say, and you want to place them in order. Now, what does that mean? You need to define what that means. Well, lexicographic ordering means that you're ordering them according to the dictionary. Now, that's a bit vague. Later when we talk about proof, you need to get rid of vagueness, no ambiguity. But so you need to check what just what that means. How do you specify the ordering? Now, lexicographic, for example, longer strings are placed after shorter ones. So the shortest possible string is the empty string, right? Eta. So that comes first. And let's say in the context of a binary alphabet, so there's just 2 symbols in your alphabet, 0 and 1. So the next shortest one would just be 0, and then 1. Well, now, and why that? Well, numerical ordering, I guess. 0 has less value than 1. Now, length is important. Shorter ones come before longer strings. Okay? So 0 and 1 are both before, precede, in order, a string of length 2, so 0, 0, which would precede 0, 1, which would precede 1, 0, which precedes 1, 1, and so on. Now you may ask, well, what about strings starting with a letter and strings starting with a number? Which one has precedence? Which one comes before in an ordering? Well, you need to check that, right? You need to define what the ordering is. So a lexicographic just means that shorter strings precede longer ones. Right? That still leaves the question: what happens if you have a string with just length 1 and it's a letter from the Roman alphabet, and you have a string also of length 1, but it's a digit, it's a number. Which of those 2 types, which has precedence? So you need to check that. How do you define the ordering? Okay, and the last definition before we get on to a whole new topic is language. Very important concept. In fact, we're dealing with it here in just a very abstract, high-level definition in just half a line, right? It's a bit of a joke, because the concept of language is very important in computer science, and we will spend several chapters on defining language and grammars and various types of grammars, and don't worry about that now. But the concept of language is really important to computer science and theory of computation. But basically, what is a language? Well, it's just a set of strings. Right? Pretty simple in that sense. So you define a language as a certain kind of set of strings. Well, I can give you a taste. Like you define a grammar as a set of rules that allow you to generate strings of a particular language. In fact, the grammar pretty well defines the language, because it specifies which strings are allowed in your language. Okay? If you didn't follow that, don't worry too much, because we'll come on to that at length in the future. Okay? So just think of a language as a set of strings, which is